Hello and welcome to today's Expert Series webinar on optimizing SQL Server on VMware data protection and disaster recovery. Today's webinar is sponsored by Heraflux Technologies and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media and I'm excited to be your moderator for this special event. Now, before we get to today's great content, there are a few things you should know about this webinar. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. Second, in the handout section of your webinar control panel, you'll find that we're offering several resources. I'd especially like to call your attention to the first item in the list. That's a SQL Server on Windows Server VMware setup guide, and you'll hear a little bit more about that later. Let's also include a link to the Gorilla Guide Book Club, where you can get access to Actual Tech Media's great printed resources on technology topics. And there's also a link to the ATM Event Center, where you can find out about more events like this one, including upcoming episodes of the Expert Series. So I encourage you to access those resources now and share them with your friends and colleagues. Third, at the end of this event, we will be awarding a $300 Amazon gift card to one lucky attendee on the live event. Of course, you must be in attendance during the live event to qualify for the prize. The official terms and conditions of today's prize drawing can be found, again, in your handout section. Scroll to the bottom and you'll find the prize terms and conditions link there. And with that, let's get to today's fantastic content. It's my pleasure to introduce you to our presenter today, David Klee. David is a Microsoft MVP, a VMware expert, a SQL Server performance enthusiast, and a virtualization architect. He spends most of his professional life taking mission-critical SQL servers and virtualizing them or migrating them to the cloud, as the founder of SQLibrium and the founder and chief architect of Heraflux Technologies. So this event is part 2 in a 4-part workshop series on SQL Server and VMware environments. 2 weeks ago, David drilled into understanding your storage options for SQL Server on VMware. So that sort of inaugural session was a great one. It was really informative, and you can find it on the ATM YouTube channel. There's a link for that also in your handout section. But today he's going to tell us about optimizing SQL Server on VMware for data protection and for disaster recovery. So now I'm going to turn things over to David.
Hi everybody, this is a deep dive business continuity session focused around how to optimize Microsoft SQL Server on VMware, largely for high availability, disaster recovery, and just good solid business continuity. My name is David Klee. I am the founder of Heraflux Technologies and SQLibrium Education. I have an absolute blast playing with some really big toys all week long. We deal with performance architecture, availability, and really how SQL Server and the infrastructure underneath it just don't really play too well together. I'm lucky enough to be a VMware V expert and a Microsoft Data Platform MVP. My contact information is on the screen here, so if you have any questions, let me know. I've been a DBA now for, 25 years, and I've been a system administrator for longer than that. A lot of folks don't quite understand what amount of pressure is placed on a database administrator or a DBA. Realistically, the primary focus of the DBA is to make sure that these databases that contain all of the critical data that arguably powers the business to be up and available. At that point, once it's running, then we have to make sure that it's fast enough to fulfill the needs of the business so that the data layer really isn't getting in the way. It's not slowing business operations down. These are the two principal tenets of being a DBA. Everything outside of that is more supporting these two purposes. The business continuity side is a real big challenge. It's much bigger than this presentation, but I want to make sure that we're aware of a lot of these core fundamentals. So the goal of business continuity is to prevent and recover a business in the event that something catastrophic has occurred. It starts with backups and restores. If you don't have a good backup and a restoration strategy, you may as well just stop. You have to have this. At that point, then we move into high availability, Then we move into disaster recovery to make sure all these pieces really line up. The scope and the scale of all of these things really depends on your organization, but you have to go through the same fundamental steps. And that's really tough. You also need to separate out planned versus unplanned outages. There will be planned outages. We have to do things like patch and firmware updates and literally reboots just to clear the memory of this stuff out every once in a while. But we also have to accommodate the unplanned scenarios. Most folks think about the unplanned side, but they don't really think about the planned side. We've got some database systems that are extremely critical and they can't patch because they can't simply take it down literally during the year. We get about one window on the holidays and that's about it. So before you touch any of the tech, make sure that the business has properly defined two strategic goals. Number one, what is your recovery point objective, or RPO? Quite literally, how much data in terms of minutes or hours can the business tolerate losing in the event that something major happens? It's not an easy question, and quite frankly, it's above all of our pay grades to define this. And don't look at the tech first. Define this value, and then you can start to design a solution around it. The same goes with the RTO, or recovery time objective. How long, measured in minutes or hours again, can this system be down at most before the business starts to really fall over, or you breach organizational contractual SLAs, or you start to lose so much money it's just not even worth it? You have to have these defined. You have to. And what I tell people, if they are not defined, the unwritten expectations are vastly different than what you may have been told. A lot of times what you've been told is, oh yeah, 30 minutes, an hour, 6 hours, 12 hours. It's okay. The second it's seriously down, there will be somebody standing behind you with a baseball bat saying, when is my business going to be back up and running? And that's not what you built the system for, because they told you, they didn't document, but they told you that it's okay. If they don't tell you, if you don't have these defined and quite literally printed and signed by upper management, their unwritten expectations are that you will have zero data loss and immediate recoverability no matter the scenario. And that's really tough because that starts to tack on zeros to our solution, and most of the time, they're not going to fund that. You have to start with these SLAs, or else I promise you, you will be in a world of hurt. You also need to be able to support whatever HA solution, and that includes the technical compatibility with a lot of this stuff. VMware does not certify specific versions of SQL Server, and this is something that some organizations really look for. They will not certify a particular version. They'll certify a version of the operating system, and that version of the operating system then supports that version of the database engine. You also need to be on a supported VMware configuration. So please take the time, review the compatibility guide. We do have some organizations out there that try to make some old equipment last a long time, and you end up with CPU scheduling, compatibility issues. You end up with just a number of challenges out there. Also, be aware that Microsoft does have 2 documents that you need to go read that are official support policies for virtualization. Long story short, they reserve the right to ask you to reproduce a problem that you may be encountering on bare metal. I haven't seen anybody ask this in forever, but it is worth reading and simply being aware of. Now, some organizations out there like to look at uptime related to number of nines. I am not a really big fan of the number of nines discussion because some people look at these as guarantees, and quite frankly, they're targets. They're not guarantees. So if we look at the amount of downtime per year, a 95% uptime at the end of a given calendar year means 18 days of downtime. That's serious. That's very significant. It's 36 hours of downtime per month. Again, that hurts. That gets in the way of doing business. So you start to go 99, 99.9, 99.99, and you end up in a situation where even 4 nines there is 4.5 minutes per week or per month. That's still not great. So we want to strive for a high number of nines. But again, it goes back. Is this planned? Is that okay? Is it unplanned? And the way I look at this, well, what if we've got 99.9% uptime, but that 52.6 minutes per year falls at 2 p.m. on a Tuesday, and then the rest of the year we're good? You still met your SLAs, but that 52 minutes is absolutely painful because it's in the middle of business hours. Now, let's do some definitions. High availability is usually a limited scope failure, usually a single component or a patching window, something like that. It's got limited business impact. Now, disaster recovery, on the other hand, this is a lot larger in scope. This is essentially, a natural disaster or the building burned down or something very, very serious. Now, an example of high availability, and again, I took all of these photos. This was a main board on a very critical machine that decided to release its smoke. And if you've been in engineering a long enough time, you realize that all electronics are powered by smoke because when they let the smoke out, they don't work anymore. This was serious. This was a 6-digit failure of this system. Thankfully, it was running in a highly available configuration. So, the outage to the business was about 10 seconds, which is still not very fun, but it's a lot more tolerable. Now, disaster recovery, for me personally, this was almost a DR incident for my house. May of 2022, we had a tornado on the ground from my house coming straight at us. Thankfully, it lifted before it got here, but I do have a photo of me looking straight up with a camera phone going, please don't drop, because it was still spinning in the air directly above my head. That's not very fun. Nobody wants that. It goes back to these SLAs. These are real-world situations here. The DBA was given the mandate of 15 minutes recovery point objective, or RPO, and an hour for RTO, recovery time objective. They missed the memo. They were doing transaction log backups on every 30 minutes, but doing them on the 15 and 45 minute of the hour. 12:45, the last transaction log backup was taken from within the database engine. 1:12 p.m., the SAN failed. That's bad. That's really, really bad. So they started recovering. This was the observed data loss. That was almost 30 minutes, and that's serious. They finally got this thing back up and running at 3:55 p.m. They blew the RPO and RTO completely. The recovery goals were nowhere near that. So they breached both SLAs. That's not cool. This almost was a resume generating event for this organization, and they ended up breaching a contract that they had with a couple of their vendors that said they'd be down for no longer than 15 minutes. Not good. Now, this is where we really have to be careful here. Certain scenarios really do need to be grouped into planned and unplanned outages, and you do need to have planned outages factored into your SLAs and your organizational, IT operations as a whole. For planned stuff, the database engine needs to be patched, same with the operating system. There could be routine upgrades of a database engine in there. There could be, firmware updates all over the place. Literally anything that's routine, you got to watch out for. The unplanned stuff are the really big issues. It's things like operating system level corruption or a bad patch or, a SQL Server outage from something big happening. Could be a VM host failure. Could be the SAN. Could be a networking switch. A lot of these things. It could be even bigger. Power outages. These things happen, especially with major, winter storms. Data center fires. We've seen 2 of these. It's scary. And then, look at Katrina, look at hurricanes and tornadoes and blizzards. It's bad. The recovery side gets more interesting. So we have to really break this down even further. Think of them as recoverable situations. So somebody green issued a database delete command and forgot to highlight the where user ID equals clause. Boom, data's gone. Somebody accidentally deleted a table. Could get database corruption. Could be a SQL injection attack from bad software that allowed somebody malicious to go do something they shouldn't have. These are scenarios we have to worry about as data professionals. Then take a look at high availability architecture. So Is the OS unresponsive or routine patching, hardware maintenance, all the normal stuff again? Same thing with DR. So SAN failures, power outages, natural disasters, all that kind of stuff. This is where things get really interesting because we have multiple layers to worry about here. We got the database engine, we got the operating system, we got a virtualization layer, we got physical compute, we got storage. There's a lot of conflicting and potentially colliding and sometimes complementary solutions in there. The database engine gives us some pretty darn good features. So from a high availability standpoint, we've got failover cluster instances, or FCIs, and I'll talk more about what these actually are here shortly. We've got always on availability groups. Now, please don't call them AAGs or AOAGs. They're just AGs. There's always on, which is a marketing term, availability groups on top of FCIs. There's database mirroring. And some people treat log shipping as HA. I generally don't. And then some people treat transactional replication as HA, which I definitely don't do. Now, disaster recovery. It's where things get even more interesting. We've got our always-on availability groups again. We've got, quote, stretched failover cluster instances. We've got database mirroring. Log shipping definitely applies here. Transactional replication, still a big no. Now, when we start to kind of zoom out a little bit, there's a lot of stuff in this infrastructure that can take care of this stuff for us as well, depending on the SLAs. VMware as a platform has some high availability or HA solutions built into it as well. There's also VMware fault tolerance. Now, I talk a little bit about VMware fault tolerance. I want you to be aware of it, and I'm going to tell you it's probably not suitable yet. So they call it fault tolerance. And what it's actually doing is allowing another virtual machine to have database, CPU, and memory changes synchronously mirrored to another virtual machine. If that host fails, that VM is literally hot and up and running on a different host with what they claim is no interruption in service. Most of the time, it works. It does have some pretty serious performance overhead. And this is a really tough one for me because I believe it's 4 or 8 CPUs, depending on what version of VMware that you're on. It's got a memory cap that's fairly low. For a big database server, it's probably not appropriate. However, if you look at things like routers and firewalls and load balancers, it's actually a really good fit for that kind of stuff. I claim that unless your database server is small enough to fit comfortably inside the resource allocation ceilings and accommodate that performance penalty, it's probably not a replacement for SQL Server high availability options. Now, you cannot use it with a failover cluster instance or an availability group. This is documented. And as of vSphere 7.0, it does have an 8 CPU max on there, which again might be a little bit low for some of your more important systems that you really could or really should have covered by a solution like this. So when we start looking at disaster recovery options, we have SAN level LUN replication, we have VM level replication, we have in-guest level change block replication. You can also do things like copy backups and stuff like that. But where do we stand from a database engine? What's better at the database versus the infrastructure underneath it? So we're going to dive into these 3 different areas and really look at what's options. Now we're going to start with backup and restores. First of all, copying a file to a USB drive and throwing it in the trunk of your car is not a proper database backup. Please, I cannot tell you how many times we see this. It's pretty scary. Part of the reason we do database backups is to get a copy of this offsite for recovery options. The other part is quite literally point-in-time recovery of your data. So we do have some options that are native inside the database engine. We have a full database backup. It's a complete backup of the database and the transaction log. I can do a differential backup, which is a copy of everything that has changed since the last time we took a full backup. There's also a transaction log backup, which may not be what you might think if you're coming from this from an infrastructure perspective. It's a point-in-time backup of all of the data that has changed since the last time we have taken a full backup or another transaction log backup. It's not like it's a regular log file. Now, let's take a really good look at our failure domains here. If I have a virtual machine and I've got a handful of database objects on virtual disk, so data, backups, normal stuff, and I'm replicating them to literally I'm backing them up to the same SAN and the same LUN that all the data is on, which is honestly very common, this can be a challenge. Even if it's different LUNs on the same SAN, that SAN is still a single point of failure. Some organizations opt to back up locally for speed and then copy them off, and as long as this meets your SLAs, I'm okay with it, but a lot of times it doesn't, because they may only back up nightly. Please review the budget for this stuff. Do that first. A lot of times it might be cheaper to have a NAS or something that you back up onto, and then that gets replicated elsewhere outside of the organization. It's still not a single point of failure. Now, other places, they may back up to a network share. Same thing. If it's another server on the same SAN, well, that's still a single point of failure. So be aware of where you're backing this stuff up to. Now, what if it is a backup onto a different SAN? Okay, that's more suitable. It's a little bit better, but it's still kind of expensive. If you need to do it, great. That still allows you reduction of those single points of failures in there. Now, if you back it up to a different network share, just make sure it's on a different target, please. Now, we need the fastest recovery path for all of the scenarios that really matter to you. So from a database backup perspective, again, this gives us a point-in-time recovery of your database data. One big thing here I want to mention on this, let's say I'm doing transaction log backups every 30 minutes. So let's say 2 p.m., 2:30 p.m., 3 p.m., etc. If I need to go recover my data, not only can I restore to 2 p.m., 2:30 p.m., 3 p.m., I can also restore to, say, 2:22 p.m. and 22 seconds and 22 milliseconds. Literally the exact millisecond before somebody issued a command to drop a table. I can have this granularity so that I have a lot more flexibility based on the recovery scenario. There's also operating system level backups. So thankfully, from a database perspective, not that much is hopefully changing within the OS. So maybe nightly or even weekly would be okay. You still have to back this up. You still have to make sure you have something to restore these databases into if you have a total meltdown. But you don't maybe necessarily have to do them as much. Now, I'm partial to virtual machines. You may have guessed that by now. I prefer virtual machines mostly because I have abstraction from the hardware. I'm not tied to drivers in the operating system that may be tied to hardware firmware versions on that physical platform. So again, that abstraction layer really does help you be able to restore this thing, especially for DR purposes. Now, we got to figure out the right backup method. So native backups, there's no additional software to back up and restore these databases onto the same or different SQL Server. I've seen it multiple times where somebody's got a third-party piece of software, they don't know where the key is, or they don't know where the installation media is, or they go to install the version of the software that they can download and they can't recover because the backups are in a different version. It's not fun. So third-party software, there's a lot of pros to it. There's a lot of features in there that you don't get natively, but there's a lot of cons. You have to have that software installed. You got to know where to install it from. You got to have the keys, whatever you normally need to go do those. And then there's virtual machine level backups. Some backup vendors out there claim to do database level backups. I claim validate that. I don't trust them until you're able to recover to a point in time and not just that periodic backup. Some can do it, some can't. The virtual machine level backup method is pretty straightforward. It's a snapshot placed on a virtual machine. It's kind of interesting. What it does is it creates a delta disk for each of those snapshots. Reads can span the delta disk or the operating system root. Writes will always go to this delta drive. Now it gets really interesting. The reads are redirected at the virtual machine disks. The writes are pushed into this delta drive, which allows the snapshot process to actually gain access to the primary virtual machine disk and get a copy of this thing. It allows that change block tracking and shared read access to those backup agents. And then it's able to go copy those virtual machine disks off to wherever they're being backed up to. If you go in reverse here, it gets really interesting. When you're done with all of this, what it will do is then it'll push all of these deltas from these files back into that primary virtual machine disk, and then they're removed, and then the process is done, and that's your virtual machine level backup. It gets interesting. It gets really deep really quick. One of the good things about VMware is that they have this thing called change block tracking that you can enable, and most of the storage vendors out there and the backup vendors do this already. It allows you to change and track the virtual machine disk blocks that have actually changed inside the virtual machine. So instead of having to copy those files off every single time, what you can actually do, you just copy the blocks. It makes that backup process a whole lot quicker. When it's done, it resets that pointer list of all the changed blocks, and you're good to go. It's fast, it's quick. Again, it may not handle what the database is doing internally. When this happens, you need to be careful. There's a stun operation that can and usually are placed on these virtual machines when they're backed up. What it does is it basically smacks the VM and says, slow down so I can catch up with everything that's changing in there. It does it when a snapshot is taken or removed, and it can cause this virtual machine to slow down, sometimes briefly, sometimes a little bit longer than briefly. You got to be careful there. If you're running, let's say, a SQL Server failover cluster instance, it may actually smack that VM hard enough to where it can take down your SQL Server HA solution and cause a failover. So if you see these kind of issues occur during virtual machine level backups, be careful. You may need to actually reduce the frequency of this or go and do some tuning in there to clean this up to make sure you don't take out your HA solution. Now, the virtual machine level backup sometimes, usually, attempts to make that virtual machine backup, quote, crash consistent. A lot of times, we don't want this because what they will do is they're going to issue a command that is going to literally flush everything, and it may actually treat that backup like a real SQL Server backup. That's going to break your backup log chain, and it might make all subsequent database transaction log backups simply inaccessible, and they're useless. We want application consistent. We want something that's going to use our volume shadow copy services, or VSS. Now, if you're looking at the error logs, you'll see commands in there for database I/O traffic has been frozen and then thawed. These are the signs that a VSS agent is actually working. Now, some organizations take Sandlun level snapshots, and that's fine, but you have to be careful with this stuff. It is not a backup. I've had some organizations, they actually treat it like a backup, but if that SAN fails, you're hosed. What these things can do, they'll do change block tracking at the SAN, and you can roll backwards to a point in time. Now, this is really handy for like global catastrophic things like ransomware attacks, but it may actually backfire. Now, if you need to use this, it's wonderful. But again, if that SAN crashes, all these, quote, backups are lost. The other thing here is if your database objects are spread across more than one LUN, and you go to revert a LUN backwards in time, you can end up with an inconsistent state because part of the database is further ahead in time than the other. You get corruption, it's just not good. Now, these do not do SQL Server transaction log management properly. So again, be careful here. You also need to really watch your backup timings. Please make sure that our backups don't overlap. So the database backups, you usually want to do a full backup nightly, or sometimes do a differential nightly and then do a full backup weekly if the database is really big. Do your transaction log backups frequently. I do them every 5 minutes in most of the systems that we manage. Do virtual machine level backups. Again, you still have to have a target to back up and restore these databases into. Sometimes nightly, sometimes weekly, depends on the environment, but that stun operation can cause application disconnects in rare cases. So as long as the ingest change is limited to those databases, you may not need to back up the operating system very much. And again, I say that carefully because I don't want you to not do this, but usually weekly is actually okay. If there's any amount of tasks that are running in the background, try to not overlap the database backups and the virtual machine backup windows. It's a lot of extra I/O. It may actually cause both to really just drag on, and that's not what you want. Now, I can't speak backups until you start talking about restores, Because if you don't validate your backups, it's quite literally a fancy paperweight or a space heater. The database backup side are easy. If you've been dealing with these things for a while, backing them up and restores of them should be second nature. I really hope you have this process automated if you're in a large enough organization to need it. The virtual machine level restores, unless you've tested restoring this, you got to watch out for it. Usually what happens here is a two-part restore. You restore the virtual machine, and then you recover the databases. So both of those have to be factored into your RTO. If you have a virtual machine level backup tool that claims to do this and can maintain a proper database transaction log backup chain, then wonderful. Most organizations don't have that luxury because those are fairly expensive. So you're probably going to be doing VM level backups and then database backups. So be careful with this. And again, test, test, test. Now, high availability, we're going to kind of step into more complex architectures here. It's really interesting because from a virtual machine perspective with the database, a lot of times these are very complementary and not really colliding. So again, go review your SLAs. And just like I mentioned before, the SQL Server layer, we have a failover cluster instance, we've got availability groups, you've got database mirroring, and then some people treat log shipping like HA. VMware, we've got VMware HA and VMware fault tolerance. Again, I've already told you not really to use fault tolerance unless it fits. The VMware availability architecture, I think, is incredibly complementary. What it basically says is that if a host just dies, that virtual machine, it's essentially like you just rip the power cord out of the back of the machine. It's down. But this agent will watch this. If a host goes down, it goes, I know what VMs were on that host. Do we have enough capacity somewhere else to go turn them on? And if so, do it. Usually, that approximate outage is about 2 minutes, 45 seconds, give or take. Is that good enough? And then the big thing for me, does this deal with unplanned situations appropriately? And then where do planned outages come in here? VMware HA will not protect you if you need to patch an operating system and that patch is going to take forever to reboot or bring it down. That's not good. Now, the VMware HA side, just like I mentioned before, it is pretty complementary to what SQL Server can do. So let's take a host cluster with about 3 hosts. Let's take an availability group architecture, which is a SQL Server HA solution. And we're going to make sure that our virtual machines don't end up on the same host. Because again, if VMware HA detects a host failure, that VM's down, and then it has to get remapped and spun up on the additional host. So be careful. Now, if you're running things in this sort of architecture, we need to go understand what our SQL Server HA options are in depth. So the foundation for a lot of this is called a Windows Server Failover Cluster, or WSFC. You may hear me refer to it as just a cluster, and I'm referring to the Windows layer and not a VMware host cluster. This is what's usually underneath either a failover cluster instance or an availability group, or sometimes both. The normal architecture for an availability group depends on a Windows Server Failover cluster to be present. They should be identical virtual machines. So literally, disk controller, disk placement, you may be able to get away with different amounts of CPU and memory, but just keep them as close, all the way down to the Windows patches. There's a validation process that you can run through at the failover cluster layer, and you have to pass that validation process. I always claim, save your report, because if you have to call Microsoft for some kind of issue, they're going to ask you, did you pass the failover cluster validation process? If you can't produce that report as needed, they're going to stop and they're going to ask you to validate that. And it may actually take longer to do this, especially if there's an outage. And that might mean that you don't get the server back up and running very quickly. Now, there are some things in here that I like to go detune. The default in here is for fast failover. So there's a handful of settings. There's same subnet delay, same subnet threshold, cross subnet delay and threshold, and then cross site delay and threshold. You can see all this for your machine if you're on the command get cluster pipe fl star subnet star. Usually the default is fast failover. I tend to actually dial this back and I want to go to a relaxed mode. It's not enough to really get in the way of the responsiveness of the availability solution, but it's enough to where if you do a vMotion or a snapshot, which imposes a stun, A lot of times, those take about a second. And these thresholds are low enough to where it may actually overreact and trigger a failover. The way to do this, again, test and verify in your environment, but if you run get cluster dot same subnet delay equals 2000, 2 seconds, 2000 milliseconds, same subnet threshold, we can actually dial these back just a little bit. Now there's a route history length option in here. You want to make this twice what the same subnet threshold is. So if you do get cluster pipe FL star route star, you'll see that value in there. When we start talking about a failover cluster instance, this is essentially a SQL Server service that is installed on multiple machines that is dependent on a Windows Server failover cluster layer. So the architecture is, in most cases, it's shared SAN LUNs that act like shared virtual disks inside that operating system. So if we take a SAN, we've got our LUNs, 2 SQL servers, we have an operating system. The normal DBA precedence is to split out data, logs, tempdb, those sort of things on multiple LUNs. The second SQL server here then connects, and literally it's sharing that LUN. Now it can see them, but what happens here is it's more of a primary, secondary sort of architecture. We have a cluster virtual IP address that in some cases you connect to, in most cases you don't. And then you install the SQL Server failover cluster instance, and that's got its own IP address and machine name, and that's what the applications connect to. There is another copy of this installed on the second machine, but it's literally turned off. You'll also have a quorum drive as like a tiebreaker, so to speak. Now the apps connect into the failover cluster instance service, and when you do a failover, here's what happens. Now, when you're in the virtual machine world, most of this is the same, but essentially we need either RDMs or vVols, or a lot of people will recommend in-guest shared storage. I really don't like that. A lot of times it's going to be RDMs or vVols. Those aren't fun. Those aren't fun at all. But they act the same. Same kind of architecture, same dependencies on everything else. But again, it becomes more of a nightmare for virtual machine or storage admins to go deal with all this stuff. It's not fun. Now, we do have some specific guidance for failover cluster tuning. Please use the VMware Pair Virtual SCSI Disk Controller. It's fully supported for all the shared disks. It's faster. It works. For the network adapters, please, please, please use a VMXNet 3 network adapter type. And you must enable Windows Receive Side Scaling, or RSS. And VMware and Microsoft have some really good knowledge base articles on both of those. There's an additional storage timeout setting that I want you to go adjust. You can reference a link on the screen here, but set this to 60 seconds or more. Because again, if you're doing a vMotion and it's supported under 6, 7 and above, you may end up with a situation where that disk timeout is hit and it's going to cause a failover. In that link, any references to MSCS should be replaced with Windows Server Failover Cluster terminology just to get everything right. Now, there's more. There's time synchronization. VM level time synchronization should be forcefully removed. Use a common NTP server in guest. Please set anti-affinity rules so that all of these virtual machines don't end up on the same host in the event that that host fails. It's not fun. You can actually leverage SMB3 shares for your SQL Server objects. Some folks opt to do in-guest iSCSI. I know there's some SAN vendors out there that actually recommend this, and I don't really like that. Just whatever you do, enable jumbo frames if you need to do this. Enable it on the storage network. If you're doing in-guest stuff, do it there too. You need it, especially for 10 gig or faster. Dedicated virtual machine NICs for in-guest connectivity really are recommended, because then you don't have to worry about active bottlenecking from anything else going on under the hood. Also, if you're doing this stuff in guest, please multipath. So either an MPIO driver or SMB direct, anything like that. Just, you need that level of redundancy, you need that level of speed. If you're running storage spaces direct, think of it like a Windows layer software. It's kind of like vSAN. You have to treat these as independent virtual machines that have very, very high networking and low latency requirements. Monitor the CPU in guest. If you're doing this, again, in guest jumbo frames, RSS on the storage network, they do eat some kernel time. You have to go watch out for this. Now, Microsoft highly recommends network adapters with RDMA enabled. It's not the most fun. VMware's actually got the PV-RDMA adapter in there. They require 10 gig networking. They recommend 25 gig networking. If you don't meet these requirements, you really shouldn't be using storage spaces direct. Now, there's a fun one in here. This is what we see the most of. These are called availability groups. But in order to show you what an availability group is, I need to show you why it is what it is. So back in the day, SQL Server 2005 introduced something called database mirroring. Now, just for the record, it is deprecated in SQL Server 2012. So let's review the basics. Again, a physical deployment. So I got two SQL servers. I've got a SAN, physical, virtual, all the same at this point. You have an operating system. I've got multiple virtual disks here with different databases, and I may split them out into database data, logs. You can park them on different or the same lines, whatever the performance characteristics need. On the second SQL server, I'll have the same exact setup. And then database per database, I could set up either synchronous or asynchronous replication between these databases, between the nodes. There's a witness server that watches them. The reason that this wasn't really the most popular, the application server had to do the failover. What happens here is it has to be aware of both of these replicas, and if one goes down, it had to know how to fail over. The hard part here is it was database per database. So let's say you're running something like Microsoft SharePoint, and it's got more than one database that the application depends on. If something happens and one of these databases fails over, well, you end up with a challenge because one of the databases is over here, another one's over there, it may not work appropriately. So in a virtual machine world, same exact thing. We're just using virtual disks in here. There's really no change from a database perspective. Now the availability group side, call these AGs. The VM administrator really is going to be treating these like regular virtual machines, but with some sensitive networking in there. It takes the best of a failover cluster architecture and gives you the best of mirroring in there as well. Again, it's not an AAG or AOAG. To a DBA, you sound really silly if you say that, and you don't want them to think less of you for that. So take the SAN, take your hypervisors, multiple data stores in here. It could be the same one if the performance characteristics line up for it again. Two SQL servers. So same thing. Give me some virtual disks, give me these databases, put data and log where they need to be, build out another SQL server just like this. Create a failover cluster between them, but we're not doing anything with shared storage. You have that cluster virtual IP address. Now, to act as a quorum, because before you ended up with either a witness server that's actively watching them or a quorum drive, which we don't want to share disk. So in this case, we can do a file share witness. Now, if you want to connect up to Azure, there's also a thing called a cloud witness. It does the same thing, just a tiny file share that acts like a tiebreaker. At this point, define an availability group. It's one or more databases that are covered by this high availability solution. Inside this availability group, we can set up either synchronous or asynchronous replication to each of our secondary replicas. Now, you can go all the way out to 9 of these things, and that's absolutely wonderful. Now, to facilitate the failover process so that the application doesn't have to know how to do both of these, this availability group can have a listener on there. It's treated just like a virtual machine, or it's treated just like an Active Directory object on the domain. But this is what our applications connect to. If you do a failover, the failover cluster layer will orchestrate with Active Directory the redirection of that listener to the secondary replica. Your applications reconnect after that connection is cut for a failover. It doesn't take long, and away you go. You don't have to reconfigure the app. Education with everybody involved here is absolutely critical. You have to demonstrate what an availability group architecture requires. It does have sensitive networking needs. So network interruption or CPU scheduling or anything that can really impact this stuff, it's going to trigger disruption, which you don't want. Please If you're a DBA out there, make the VM admins aware that these are in an availability group. They need to set up an anti-affinity rule to make sure that they don't accidentally end up on the same host, because all the time and planning and effort you spend on building your HA solution is useless if that host fails and everything goes down. One thing at a time. Set up your affinity rules. Do your VM movements separate from the times you're doing backups or big batch operations, things like that. Try not to do them at the same time, please. Now, disaster recovery, again, this is where not only can it be complementary, it might actually replace a database solution depending on what you have available and what your SLAs actually are. I claim these can be pretty darn complementary. If we take a look at SQL Server, we have a backup, a database, copy, restore options. We can do a stretched failover cluster instance if your DR site is close enough where it could be synchronous. You've got availability groups that we can do in an asynchronous manner, and then you've got log shipping. From a VM admin perspective, you can replicate the virtual machine level backups. You can do VM level replication. You can do Sandlun replication. You can do in-guest operating system replication. Again, what do we need? DR is not an easy one solution fits all architecture. It goes back to these SLAs. You have to work with all the organizational members and all the teams, because what they think may work best for them might actually breach the SLA for some of the organizational units in there and some of these pieces of software. So who manages DR? Is it individual members from each of the teams? Is it a single team? This is really interesting because we have some organizations that we work with that will actually have a lower SLA, meaning they can lose more data. Also, a single team can manage and promote this stuff if there's a problem. What's your current strategy? Has it been discussed between all these different groups? Is it complementary? Can a VM level backup actually augment or even replace a SQL Server DR feature? And again, it all goes back to these SLAs. So what's the best plan? Discuss with everybody involved how SQL Server HA and DR features fit with that organizational business continuity strategy. Do the plans. Look at the budget. If the budget doesn't line up with the plan, you either have to reduce your expectations or change up your plan in order to go fit. And this goes all the way up to the C level. And again, just like with anything else, please don't overcomplicate your design. You don't need complexity in the event that you're dealing with a natural disaster or something very serious. And again, what good is a business continuity plan if you haven't tested it? You have to test this stuff routinely, multiple times a year. Now, just like with everything, question everything anybody on a webcast ever tells you. Always, always, always test. But when you do, your business will be much more protected. You're going to lose less data. You can actually sleep at night. So thank you all for listening, and let's open the floor for some questions.
All right. Great stuff, David. And so there are a bunch of questions rolling in. Are you ready for them?
I am.
All right, super. This first one, out of planning a business continuity strategy, what's the hardest single piece of it?
It's going to sound absolutely nuts to a lot of folks out there, but the hardest piece that I find is getting an organization's management to, quite frankly, define the SLAs. It sounds nuts, but a lot of times they're not willing to commit to a certain SLA. And I'm honestly not certain why. But if they don't, what you end up with is you're shooting at an open target to try to figure out where to go hit. And, the unwritten expectation is always best effort, best possible, but nothing is going to be good enough until they can actually define those things.
Those are great points. And I wonder as well, a lot of members of our audience, are, internal in their, their organizations, like DBAs and such for, within an IT department. Do you think there's an element of that that's, because you're a consultant, people want to leave that gray area so it's a little squishy and they can put it on you? Or do DBAs face that kind of challenge as well
DBAs
within their own
face
organization?
DBAs face this a lot because when I go and approach organizations on this, I really try to be non-confrontational with it. And it's literally, what can the business tolerate and withstand related to high availability and disaster recovery, just as a whole? Throw away the tech before we can actually start designing a solution. Because if we don't have those targets, nothing is going to be good enough. And as a consultant, I have to have those, or else nothing I do is going to be good enough in the event that you actually need it. And
Right,
the DBAs
right.
of the organization are in the exact same boat. A lot of times they simply can't get this from their leadership as well.
Yep. Definitely tough to get people to prioritize, right?
Well, it's
About what's
prioritized, and
really
I think
important.
it's prioritization, but I think part of it is also they don't want that level of liability on them, because
Mm,
if something critical does get lost, with having to revert a system backwards in time, and the business now said this is acceptable, but it turns out to be really bad, they lost something major, it's their neck on the line at that point. And I get it, it's self-preservation, but we're talking about the business as a whole and not just your role or sticking your neck out. You have to be able to define this stuff.
yeah. Yeah. And we actually got a question from Ken sort of along these lines. Ken says management does not understand the importance of SLAs or why they have to pay attention to them until there's a serious outage. And
Mhm.
he's wondering if you have any advice for getting their attention.
Boy, to get their attention, be factual. Literally say, I need you to give me a target, because the way the current system is designed right now, if the poop hits the fan, you're looking at a day's worth of outage. So, can you tell me, if you have to redo work, if it's even possible to redo the work, how much is it that the business will actually burn in an hour or a day? Or what contractual organizational guarantees have you made with your clients on this stuff? And some of the folks we work with, they have multi-million dollar SLAs for availability, because they're like e-commerce and financial transactional systems. They have to be up, and a lot of their customers require guarantees. You need to know those. So if you can help the organization understand the financial impact of it, and not just, yeah, it's going to be down for a little bit, that's how you can really get their attention.
Right. Okay. Yeah, and Ken also adds, when executive management does finally commit to an SLA, they often don't want to fund the SLAs. But
And
let's
and
let's
that's
move on. Yeah.
yeah. Well, I'll just say, if they won't fund the SLAs, you have to go back to them and say, look, you're unwilling to give us the budget to give these SLAs. So either give us the budget or reduce your expectations, but put it in writing that your expectations have been reduced, because that's what we're building to. And
Right.
if they won't
Right.
do that, then quite frankly, I would look for another employer, because it's your neck on the line, because they're unwilling to give you those targets to go build to.
Great points. Okay, let's move on to some technical questions. We have one from Brian, wondering how many databases can be in an availability group.
Ooh, good question. The official guidance from Microsoft is roughly 100. If you manage your worker thread allocation appropriately, I've been able to do up to about 300 stably. I wouldn't do anything beyond that.
Okay. All right. Super. Um, Khan is asking, does the WSFC validation process need to be run while things are working perfectly and before there are issues with a VM or VM server?
Great question. Short answer is absolutely. What I like to do is actually run that validation as part of the creation for this. And then once you're up and running, do it again before it goes live. Save that report. If you ever need to contact Microsoft support for anything, they will ask you if that cluster has passed that validation. If you don't have a copy of that report, you may not be able to get into it to actually show them. So they may ask you to jump through some more hoops. And if things are down, you kind of need that up and running now. So what I always tell people, run the validation. It's quick, it's easy. Save that HTML output, put it somewhere off of those machines, somewhere that you can get to it if you need to. And if you absolutely need it, it's gonna save you some time and hopefully help you get that stuff up and running a little bit quicker in there.
That's a great tip. It sounds like some hard-won experience there on the not being able to access the report.
You have no idea.
Very
There's a
nice.
lot of
Okay,
gray hair in that
Rakesh.
one.
Rakesh is asking, can we have clusters in on-prem and Azure cloud, and is there a performance impact in such cases?
So I may answer this with another question. You can have clusters on-prem. You can have clusters in the cloud. So failover clusters themselves. If you would like to stretch them, you're going to need to make sure that your latency between the sites is incredibly low, and you're going to need to use something like, honestly, Sios Data Keeper Cluster Edition. Probably not even storage spaces, just because of the networking requirements. And if you can't meet all of those and have extremely low latency between them, I would not recommend stretching it. But to have in one or the other, and then potentially use an availability group to replicate your data on top of an FCI, that's definitely doable, and that's something that we see a lot of.
Okay, super. And Bradford is looking for your opinion on database as a service versus infrastructure as a service.
Do we have the rest of the week on this one?
No, we've got about 3 minutes.
I will be extremely brief. Standard DBA answer here is it depends. I personally I could seriously spend an hour talking about the pros and cons of either. And quite frankly, I'm tired of patching operating systems. So if you have a workload that can work well, both from scale and performance and manageability on a database a database instance as a service or a database as a service, by all means, do it. You don't have to patch the stuff. It just does it automatically for you. But there's a lot of limitations that come along with those, both for scalability. And if you have some code that's got some practices that, we're not exactly proud of, sometimes it just simply won't work in a database as a service or a managed instance. And sometimes we have to go with infrastructure as a service or literally virtual machine in the cloud. Or sometimes the workload works with it, but maybe the SLAs don't. Maybe we need better SLAs than what that platform can provide. So there's tons of nuances, tons of talk about on there. That'd honestly be a really good topic for a future presentation, simply because it's one you can quite literally spend a good 4 to 8 hours comparing and contrasting those solutions.
Okay, well, let's put a pin in that for a potential future session. That
Yeah.
sounds great. Hey, before we wrap up, David, I did want to ask, can you talk a little bit about the document that you provided in the handout section about
Absolutely.
what that's good for?
Yeah, this is one that so VMware Corporate has a best practices guide out there, but it does not have a lot of specifics. What I've done is over the years, I've compiled my own internal build guide, and this is essentially my checklist for how I get started with building a brand new SQL Server in a VMware environment. We've got them for cloud and Hyper-V and all that stuff, but I figured since this one is VMware specific, let's focus in on that. And essentially, this becomes my checklist. Again, it's not the end point, but it's a starting point. Everybody's got their practices with drive configurations and all that. But this gives me that basic checklist to use when I want to standardize on a performance tuned template for SQL Server on VMware deployments. This is where I go. So for all of you out
All
there,
right.
let me know if you have any questions with this. This is one of our internal guides that we finally decided to open up to the world.
Well, I appreciate you sharing that on this platform in this session. It looks like a great resource. Well, David, I think we're about out of time. If somebody wants to get deeper into optimizing SQL on VMware for data protection, disaster recovery, any parting recommendations?
Absolutely. Yeah. If you want to really do a deep dive on this topic, check out SQLibrium.com. It's one of our two businesses. It has about an 8.5 hour training course on there. It's all video driven, on demand. It will give you the deep dive on performance tuning, availability options, license optimizations, capacity management of SQL Server on VMware specifically. If you want any help
Okay.
with any of this, my consulting company is Heraflux.com. We have a lot of fun playing with some really big toys every day to help folks squeeze the most out of their data platform investment.
Okay, yeah, super. And that the SQLibrium link is in your handout section. And I should also say there's a link to the ATM Events Center in there, where you can find the registration page for the next event in this series, which is on April 1st. Not a joke. And that's on securing SQL Server and VMware environments. And then David will be back on April 22nd for another session. So um, we hope you can all tune in again. And David, thanks for a fantastic presentation. As always, it's great to hear from you.
You're welcome. Thanks, everybody, for joining and watching this after the fact if you're doing that. And if you have any questions, reach out. I'd love to hear how you like the session. And honestly, if you have any ideas for future sessions, let me know.
Yeah, please do let David know or let us know, and we may follow up on that. And before we do wrap up, we have one more piece of business. It's the $300 Amazon gift card prize drawing. And the winner of the $300 Amazon gift card is Adam Palafox from California. So congratulations to Adam. We'll be in touch to get you your card. And with that, on behalf of the actual Tech Media team, I want to thank David Klee and Heraflux for making this event possible. And thanks, as always, to all of you for attending and for your great questions. That concludes today's event, and we'll see you next time.
Thanks, everybody.